Our topic for today is all about normal distribution. Lesson 1. Understanding the normal curve. Let us tackle first the properties of a normal probability distribution. Number 1. The curve of the distribution is a bell-shaped. The curve is symmetrical about the mean. This means if we will cut the curve about the mean, we can say that one is a reflection of the other. The mean, median, and mode are of equal values, and when sketched, they coincide at the center of the graph. The width of the curve is determined by the standard deviation of the distribution. A standard normal curve is a normal probability distribution that has a mean value equal to 0 and a standard deviation equal to 1. The curve extends indefinitely approaching the x-axis, but never touching it. Thus, the curve is asymptotic to the line. The area of the region under the curve is 1. It represents the probability or percentage or proportion associated with the specific sets of measurement values. Here is the table of areas under the normal curve. Steps in finding the area under the normal curve given a z-value. Step 1. Express the given z-value into a 3-digit number. Step 2. Using the z-table, find the first 2 digits on the first column. Step 3. Find the 3rd digit on the first row on the right. Step 4. Read the area for probability at the intersection of the row, first 2-digit number, and column, 3rd digit number. The value observed at the intersection indicates the area of the given z-value. Example number 1. Find the area that corresponds to z equals 2. In finding the area that corresponds to z equals 2, it is the same as finding the area between z equals 0 and z equals 2. So we will follow the steps. So step 1, express the given z value into a 3-digit number. So since z is equal to 2, it becomes z equals 2.00. Number 2. Using the z-table, find the first 2 digits on the first column. So we will look for 2.0. 2.0 is here. Step 3, find the 3rd digit on the first row on the right. So we will look for 0.00. 0.00 is here. Last step is to read the area for probability at the intersection of the row, first 2-digit number, and column, 3rd digit number. The value observed at the intersection indicates the area of the given z-value. So the area at the intersection is 0.4772. So we have here the area at the intersection of 2.0 and 0.00 is 0.4772. Find the area that corresponds to z equals 1.45. So in finding the area that corresponds to z equals 1.45 is the same as finding the area between z equals 0 and z equals 1.45. So we have here in the first column 1.4. Lastly, we will read the area for probability at the intersection of the row, which is 0.05, and column, which is 1.4. So the area at the intersection is 0.4265. So here is the intersection of 1.4 and 0.05. Example number 3. Find the area that corresponds to z equals negative 2.5. So since the normal curve is symmetrical about the mean, therefore, finding the area of z equals negative 2.5 is the same as finding the area of z equals 2.5. We will express z equals 2.5 into a 3-digit number. So it becomes z equals 2.50. Next, using the z table, we will find 2.5 on the first column. Here is the 2.5. Find the third digit on the first row on the right. So find 0.00. We have here 0.00. Here is the intersection of 2.5 and 0.00.